Hello guys, this is your instructor Mac, and today we'll be starting off with the third lecture of IAS Unit 1 Motion Concepts. In today's lesson, we will be discussing and understanding the concept of acceleration on a freely falling object and the experimental details. We have to find the acceleration due to gravity by free fall, and we have to discuss a couple of experiments regarding that in a lot of detail, because these experiments can be asked in your examinations for as up to 6-7 marks. 5 markers are very common, so let's start off with that. The first basic experiment that comes in our syllabus about gravity is this one. There is this iron ball that we initially place in rest, and then this iron ball fall, and then we have a timing gate that actually starts with an electronic timer at 0, and as the switch starts, let's say if I start the switch, this solenoid would be magnetized, and then when I open the switch, the timer starts, and then the ball drops. And then as the ball drops, as the timing gate is as the ball hits the timing gate, we actually note down the time. That is the time for the ball falling a certain height. In this experiment, we are to change the height. Therefore, height became independent variable that we are changing, and then time became the dependent variable. So this is basically an experiment. Although this electronic timer, start switch, and all these things are basically just to make the experiment to be very accurate. But otherwise, the experiment is very simple. You have to drop a ball, note down the time it took to actually go down, and then height is the displacement that is covering, and time is the value that we have, and we need to find the value of gravity. Now in the experiment, the equation that we are going to be using is S is equals to ut plus half at squared. This is the equation that we'll be using, and we will always be using u as 0. That would be the initial velocity. We'll start off with that, and then measure measure S, which is h by a meter rule, and h will be in meters. You are required to measure the time in the experiment. Note time by the electronic timer. So electronic timer is used to note down the time. If you were to realize, this equation would be slightly changed, and it would become S. Basically, it would become h is equals to ut becomes 0 because it starts from rest, half, and a becomes gt squared. This is going to be very basic understanding of the equation, because since you are done with unit 3 as well, or you have discussed unit 3, or you'll be discussing unit 3, this comes up a lot. Since it's going to be a 5 marker, you have to actually realize that on x-axis, always the independent variable. Independent variable. Therefore, we'll be plotting the height that we are changing. So first of all, we'll make t square the subject. So the equation would be t square equals 2h over g. This would be our equation. 2 over g, and then I would just round it off first. If I were to y is equals to mx or plus c, c is 0. So graph starts from origin. Graph is going to be starting from origin. M will be 2 over g. That's the value of gradient. Height comes on the x-axis and t square comes on the y-axis. So t square against h, I'm gonna be plotting t square against h, and then my gradient will be equal to 2 over g. So g will be equal to 2 divided by the gradient of the graph. So I'll be plotting the graph of t square over here and h over here. Graph is going to be a straight line passing from the origin, and then and there I'll be getting the value of g. Let's read out the points. Okay. Compare the equation with the equation of straight line. We plot h on the x-axis and t square on the y-axis to give a straight line of best fit that I told you. The gradient of the line will be giving 2 over g that I told you. We can find the value of g by taking measurements from the experiment using the equation to calculate this. Yeah, we can easily do that, or we can do the gradient is equals to 2 over g, and then just g will be equal to 2 over gradient. That is pretty much everything that we need to know. However, a single measurement in an experiment is subject to uncertainty, so we'll be taking average. Take multiple readings and take an average. This experiment is asked in your examinations quite a lot of times, and they have given it up to 5 or 6 marks. So you have to be very, very sure what you're writing. The marks distribution goes in a way, for example, they will give you equation mark, you'll write the SI units of the stuff, you'll do the correct plotting, and then you'll write that graph starts from origin. What are you plotting against? What are you plotting? You have to write that. Then you have to give a way to get the gradient. For example, the gradient is going to give 2 over g. So you can easily get that. Or otherwise, even if you get multiple values of t square h, you can even put it in the equation. So t square values and h values, you can put multiple values and get the value of g, and then take multiple readings and take an average. So this is going to be the basic understanding of how you're going to be writing the equation and how you're going to be doing the experiment of the free fall. There's one more experiment. Before doing that, let's move on to the question that we have just discussed. Now, in your syllabus, they are saying that a student carried out an experiment to measure the acceleration of free fall g. A ball bearing was released from position A. The time t of the ball bearing to fall a distance L was measured. This was repeated for decreasing values of L. So they're basically changing the values of L. Experiments explain how the measurements obtained can be used to determine the value of g in meter per second square. Your answer should include a sketch on the axis below. Okay. Now, first of all, whenever this question comes up, you have to write S is equals to ut plus half at squared. You have to first write that variable, or because we're going to be changing the value of L, and determine time. So this is number one. So you're going to be varying the value of length, and then you're going to be determining the value of t. So just because I'm not writing the answer, I'm going to be writing everything, but not in a paragraph form. This variable, it's independent, and this time is dependent on L. And then explain how the measurements obtained can be used to determine the value of g. Okay, use your sketch. Okay, first of all, you'll keep initial velocity as 0. Keep u is equals to 0. So the equation will be S is equals to half at square, where now S becomes L is equals to half, accelerations becomes g and t squared. Alright, if we agreed to this, we would make t square on the y-axis. So t square goes on that side. That will be 2 over g and then L. So y is equals to mx. Gradient will be 2 over g, y will be t square, L will be x. So first of all, you'll be writing t square on the y-axis, and L will be written on the x-axis. And the graph is going to be a straight line passing from the origin. And then you can say that gradient will be equal to 2 over g. So g will be equal to 2 divided by the gradient. If you would realize in detail that they only ask you to explain how the measurements obtained can be used to determine the value of g, your answer should include a sketch on the axis below. Okay, so t square is in second square, length is in meters, expect to obtain. Okay, and that the and x is below, and the graph that student would be expected to. So yeah, you'll get 2 marks just for the sake of this graph. You'll just get 2 marks for that. You'll get a mark for the equation. You'll get the mark for actually making it something like this, and then you'll tell how the gradient is to be obtained, and this is everything that you need to write in your answer. You can explain it in wordings, but this is something that I think if you do it, you'll get all the marks for all 5-mark questions. Now, there is this second way they can ask this experiment. It is a light gate way of asking it, and I call it the light gate experiment. This is again asked a few times in your examinations. Quite important. This experiment is also quite important. And to discuss this, I'll be like explaining it on an actual question of your IAS exam, just to be very clear, so that like there's nothing missed or like understanding issues. Okay. Now the student carries out an experiment to determine the value of g, the acceleration of free fall. The short wooden rod is released above the light gate. A timer is connected to the light gate and it is used to measure the time taken for the wooden rod to pass through the light gate. The experimental arrangement is shown. The student uses the equation v square equals u square plus 2as, where u is equal to 0. Okay, and the graphical method is okay. State the additional measurements of the student takes. Okay. I'm just going to be explaining you the experiment first, so that you can actually understand what is happening. There is this wooden rod, and this is also a very common and very important experiment. This wooden rod is like dropped from a certain height. So initial velocity of the rod is 0. That's one. Equation that I'm using is v square equals 2as, because u is 0. Just to first of all, I'm just making you understand the concept. When this ball drops, this wooden rod drops, I'm calculating till this point, and that's it. So there are 2 things that I need. First of all, I need the height from which I am dropping. Just to be making it, I'm just going to be explaining it to you. I'm dropping the rod. This is not an answer to anything. I'm just going to be explaining something first of all. So if I have this height, that actually is the value of displacement that I have to put in an equation. Second is, I'm going to need the speed, like the final speed over here. I need a speed over here. So for that final speed value, since I've got a timer attached, if let's say this rod starts inside and then come out, so the length of the rod, whatever the length of the rod is, this is the actual distance the rod is going to be covering, like the time it is in the timer. And then if I have that distance, that is basically the length of the rod, and if I divide that value with the time, we can easily get the final speed. So for V, what I would need is the length of the rod, and for S, that is the height from which I'm going to be like dropping the rod. In the question, they have asked you state the additional measurements the student should take. So number 1, for S, the student needs the height at which the rod is dropped. Number 2, for the V, I would need the length of the rod. If I have these 2 things, I can easily calculate the value of G. Okay. Moving on. Describe how the velocity of the wooden rod as it passes through the light gate can be determined accurately. So how can we determine the value of velocity? It's quite simple. Velocity is equals to distance over time, but the distance is going to be in this case the length of the rod. Velocity is equals to distance, that in this case is basically the length of the rod. And the time, that's the thing. So for the time, I would take time of the timer. So this would give me the time, like how much time the rod took to fall through that timer. and then the distance is going to be basically the length of the rod. So I can just do that, and that would just only give me one mark. I have to average it. So average it with multiple readings. Always remember, such a question, you have to average it, determine the value accurately. So accurately, you need to actually analyze what is to be done to make it more accurate. That in this case is going to be averaging. Okay. Now they're saying that describe how the student can determine the value of G using a graphical method. So if I were to use a graphical method to determine the value of G, first of all, you would analyze that I've got two things. First of all, I've got an equation v square equals 2as, because u is 0, that's why. And since I'm changing, so I'll just make sure v square equals 2a, and the length is called what? The length is called s, so I don't need to put the variables. Okay, s is the length that I'm going to be changing. So since I'm going to be changing that, it's already on the x-axis, so y equals mx. So yeah, one more thing, I can write a as g because it's gravity. So yeah, okay. So in the y-axis, I'm going to be placing v square. That would be m square s minus 2. You can even write that down. And x going to be length, that's L in meters. And then I'm going to be writing it as the graph is going to be a straight line passing from the origin, definitely. So gradient will be equal to 2g. So if I need g, the gravity value, I need to do gradient and then it had to divide it by 2. Well, that's it. And then I'll like to start, graph starts from origin. Origin will be a straight line and the gradient will be equal to 2 times gravity. So this is the graphical method that I can use in order to find the value of G. And this is the final experiment. So in this lecture, we discussed everything related to the experiment of determining acceleration of free fall. There were multiple ways to do it, and I'm pretty much hoping that you can do any question that comes up regarding this. In the next class, we'll be doing starting off with the graphs and the passwords. Regarding the graphs, stay tuned, subscribe the channel for all the batches, and like there are like 15 extra lectures that is premium and that can be given to you if you ask for it. WhatsApp link is given in the description. Always ready to help. Take care, guys. Hello guys, this is Sir Mahad Amer and welcome to another lecture. Since you're enjoying the lectures, just wanted to inform you that there are premium batches going on. That is a direct way to get A's and A stars. It has got some exclusive content that is not generally available neither on the website nor on the YouTube. So you can join the batch to get your grade.